Okay, welcome back everyone to SERX Part 2. You're all joining us in Room 2, and I look forward to the last 4 or 5 conventions, clinics that we're going to run. I'll hand it over to the host for Part 2. Perry, take it away.
Hey, good afternoon, folks. Welcome back to Room 2. It's a very nice room. This afternoon we have, starting off in Room 2, Tom Gordon. Tom Gordon is going to be talking about Arduinos and Raspberry Pis, oh my. Tom interned virtually under Dr. Victor Frankenstein. Tom has worked diligently in the areas of invigorating lifeless model railroad layouts. As a child, he first started with powering all of the turnouts on his layout and is now moved into simplifying the interface between layout operator and the physical layout itself. Through spreading the knowledge of small computing devices, he hopes others will similarly make their layouts more intuitive to operate, increasing everyone's enjoyment of the hobby. And here is Tom. All yours.
Okay, thanks, Perry. Before I get into the PowerPoint and hit you with lots and lots of slides, I wanted to show you a few things. I generally do this presentation live, and I can hold stuff up and pass things around. And, gee, that's kind of nice, but unfortunately, can't do that. So I'm going to be talking about Arduinos and Raspberry Pis. First thing I'm going to show you, just to get you an idea of the scale of these little beasties. This is a Raspberry Pi in a case. This is a deck of cards. This is a full-blown computer. Anyway, Arduinos. This is a an Arduino Uno. This is one of the more common ones people will use. And you can get them as small as a Nano, or I'll show you a Pro Mini is this board in here. Really, really tiny stuff. So I just wanted to give you an idea of the scale we're talking about, because without the boards there, you can't really look at it in front of you. So I'm going to move over to showing the presentation, and we'll dig right into it with a little cooperation. There. So what I'm wanting to do is get people interested in using small computers and how to make them handy. They're amazingly capable. Yes. Oh, how do I get PowerPoints to share?
It's almost in the center of the Whereby window.
Oh, the share? Yeah, I thought I
Yes.
clicked. There, okay. Oh, and share here. Okay, this, share. Got it? Okay, sorry about that. Oh, and here we go. Is that better? Ah, fabulous. Sorry about that little technical difficulty there. This is a picture, for what it's worth, of my previous layout, which no longer exists. But I did use Signals, I used Arduinos, I used Raspberry Pis, I used all that good stuff on there. And we'll talk about how you can use them themselves. I want people to clear the mystique of the hardware and the understanding of what it takes to use these things. These devices are amazingly powerful. They're really, really cheap. And instead of buying banks and banks of relays and all kinds of other things, you can do a lot of your work digitally. And and save a whole ton of money and have a lot more capability. I was inspired in a lot of respects by the people at Model Railroad Control Systems. And they have some really great things using small computers. And Dr. Jeff Bunza has done some fabulous articles I'll refer to a little bit later on how to use Arduinos. But there are a lot of things you might need to know to make life a lot easier dealing with these. So I want to make it easier so you can wow me with your layout. So initially, let's start with what an Arduino is and a Raspberry Pi, and I'll get to some pictures in just a second. We'll talk about how their costs, their price points that are out there, which by the way, change all the time, but they're really not too bad. Tools and things you might need to be aware of, and things to be careful about, and mistakes I've made. I'm not going to show you any code. Reason I don't want to show you any code is, for heaven forbid, I don't want to have to help you debug it. But regardless, you can get a lot of code on the internet, and if you know anything about coding, you'll find these guys easy to do. I'm not an expert in Arduinos. Regarding the Raspberry Pi, I really don't know a whole lot about Linux, which is the operating system. I can get them to run. They're really not hard. Pis run the version of Linux, and you can download JMRI onto them, and it works beautifully. I program my engines and run my layout using Raspberry Pis. I got tired of using desktops. Also, a lot of books about programming Arduino devices, and I'll give you a reference at the end, but most everything you need is really online and free. Okay, a Raspberry Pi. It's a small single board computer. It runs very much like Windows or Mac. It has a nice graphical user interface. They were designed to get folks involved into computing when they couldn't afford a computer. A lot of the Pis that I use cost me a whopping $35 on Amazon. There's some cheaper versions. There's some newer versions that cost $45, $50. But it has everything you need to get things going. Now, you may want to get a micro SD card. Actually, you're going to need to get a micro SD card for things to work on it. But it's a very simple process to plug the SD card in or to download the software for it. There are no moving parts on a Pi. There's no fan. It just sits there. You're going to need a heat sink, though, believe me. An Arduino, on the other hand, is a small single board microcomputer, often called a microcontroller. One of the Arduinos, or an Arduino, runs one program, and it runs it in a loop. It runs it around and around and around and around, and it keeps running the same thing over and over again. So if you push a button and the Arduino recognizes you pushed a button, it can then respond to that button and maybe turn an output on or off. They were developed in Italy. It was initially, my understanding, it was done in the artist community. So all the programs are called sketches. They're cheap. One of those I showed you cost me $2. The really, really tiny ones. Now, $2 doesn't give you an official version of the Arduino, but I don't care. Spent $10 and got 5 of them. So things are good on that. Now, I would be passing around stuff to you at this point, but I can't. So I'm going to show you some pictures of some boards and try to talk to you what exactly is on those boards and what's handy for using these devices. The upper left-hand corner of this particular screen is an Arduino Mega. A lot of people like the Arduino Megas because they have like 50, 60, 70 input-output pins. You can see them on the screen. They're there, it's there, and you can plug plugs into them, running signals or what have you. The upper right-hand side is an Arduino Leonardo. I'm showing it mainly because you'll see another picture of a Leo later on that's configured a little bit differently. It has a few different characteristics of the Mega. but it works. The lower right-hand side is a clone of an Arduino Uno. Works quite nicely. Significantly cheaper than the real version that you can get. And just as a caveat, sometimes they don't work as well, but I've never run into any problems. The Pro Mini clone and the very bottom is unassembled. It has pins in there. You need to do a little soldering with this guy, but you can put pins or plugs and what have you on it. And then there's the Nano clone that's on the left. I'll show you one of those in reality in a bit. All the Raspberry Pis have a similar form factor. They all have USB ports and network connections. And at the bottom, you can see there's an HDMI output for video. It has the ability to input video and to output video, and the output to show a touch screen. There's an audio jack at the bottom, and a lot of pins that you can program at the top. Now, I'm throwing in some things called voltage bucks here, because they're really handy when you're dealing with these, any of the Arduinos or the Pis. Voltage bucks work very similar to computer power supplies. They maintain a constant voltage, which these devices actually need. You can get them with variable voltage. You can get a nice display on some of them. Just want to show you a few of them, and I'll talk about them in a bit. There's a fixed voltage device on the lower right-hand side, and it is really tiny. I put these in passenger cars to maintain the voltage. So, are these devices toys? A lot of people think they're toys. They're not toys. The original PC, as you can see the specs there, they were not too bad. An Arduino Pro Mini, which was one of those tiny ones, has more capacity than the original IBM PC. Needless to say, it's significantly cheaper. The Raspberry Pi 3 is even more capable and has all kinds of software with it. So regardless, they're not toys. These things are real, and a lot of them, more the industrial grade versions, are used by in industry. So there's so many different Arduinos. A lot of people get confused. Which one should I use? I use which one fits where I want it to be. Don't worry about the different kinds. If you're using it typically for a model railroad, most of them will do input and output to different pins very, very easily. Now, the official versions of Arduinos, not the knockoff versions that I often use, will work with impunity with add-on boards, approved add-on boards called shields. These shields add capability to the Arduino. You can get shields that do Wi-Fi and Bluetooth and other things like that. So if you're wanting to make sure that something works with the shield, you may want to make sure you get a genuine Arduino as opposed to something that's more of a counterfeit. However, I've found generally the counterfeit ones work quite nicely, and they're a little bit cheaper on the price. Useful hardware that you may find. More of the handout boards. The picture doesn't come out quite as nice. Those pin headers on the left are straight pins and right angle pins that allows you to mount the Arduino however you wish. There's screw connectors. The lower right hand side is rather interesting because you can put the pins through a board and stack boards. These are all things I'll tell you the source where you get them. Just things you need to be aware that are available that can be very, very handy with dealing with Arduinos. There are add-on boards. The upper left-hand one is one of my favorites. I'll talk about these a little bit more, but they're relay boards. They have single pole, double throw relays on them. They run off of 5 volts, which is handy because an Arduino likes to eat 5 volts. And you can actually turn one of those relays into a double pole, double throw, a pair of those relays into a double pole, double throw, and use it for a reverser. There's prototyping boards, which are handy when you're trying to create a circuit. The upper right-hand side and the lower left-hand side is one that's kind of populated. Not to do advertising for model rail control systems, but that particular board on the lower right-hand side plugs into what they call a bare bones Leo or Leonardo and runs as a node on the computer model railroad interface. It's the CMRI system that Bruce Chubb developed. And Bruce, by the way, is quite aware of these systems and does like them. They're a lot smaller than the original boards that he used and works with impunity. Pins and sockets. These make things a lot easier. Now they're tiny or very, very small. You can buy pre-made, what they call DuPont plugs and create your own wires and plug them into it and develop and build your own pins or your own sockets. The pins and the plugs and the sockets actually come on those metal strips down there at the very bottom. I found it's very good to use those. I use them in a lot of places. I like to use them on signals because I can work on a signal on the workbench and have everything sitting there on the workbench, and test it, and then just go on the layout and plug it in, and life is good. There are also KK style sockets that you can get from more of the industrial grade suppliers like DigiKey and and Mouser, excuse me. The device on the right, the white board, is a bare bones Leo or a Leonardo. You can see how I've expanded its capability, and I had a whole boatload of signals running off of this that I was able to label on those nice white plugs and identify exactly what the signal was or the signal head was. So again, you create your own plugs, you put them in, and things program it correctly, and things work well. So one caveat: you're using all these wires. There are a lot of wires. Make sure you document where the wires go. Make sure you label the connecting plug and plan all your wiring before you wire the layout. A lot of people try to retrofit all their wiring, retrofit the labeling. Not necessarily a good idea, especially when you're dealing with something that involves this many wires. More pins, more sockets. There's another board I would pass around. It's not that big a deal, but it's it shows you what's available commercially. The very bottom, you can get like a 6-pin plug, 6-pin socket, and use them all you want. You can strip the wires out as you wish and have a real good time. And the pins and the sockets and the wire are not expensive. You can get them on Amazon. Breadboards, very handy when you're testing a circuit, when you're testing LEDs, you're testing your signals. Breadboards are very nice to have. Just wanted to show one. I'll use them a lot, and I'll test things, and then I'll go ahead and solder something together and use it. Now, they're canned add-on boards, the Arduinos that I had mentioned or talked about a little bit earlier. They're called shields. They expand the capability. You can do a whole lot with them. The commercial vendors like SparkFun and other ones, I'll give you a list of vendors in a little bit, have a lot of these boards and a lot of them available. People use these and just everywhere. You'll see people doing robotics and drones and other things using Arduinos, and they use these shields to import or export or deal with video or sensors and other things. They just plug right into the board, into the Arduino, and it expands its capability. Granted, you have to do a little bit of code, but the vendors always supply the code you need to get it to work nicely. Back to those relays. Here's a bank of 8 of them. I know that Amazon sells 6 of these. 16 bank relays. They plug directly into an Arduino by a cable. You can see the pins down at the bottom. I'm hoping my mouse shows. You can see the pins down here. They plug into the Arduino, and the Arduino can trigger the relay. This allows you to use high voltage or high current devices from the Arduino, because an Arduino doesn't really handle much current. An Arduino can handle the light of an LED, but beyond that, it gets to the point where you could easily burn out the board, and you really don't want to do that. So let's talk about some useful tools. There are things that you can have that make life a whole lot easier using Arduinos, and for that matter, Raspberry Pis. Also, you'll find some of these are useful for DCC installations, for putting receivers in locomotives, for wiring signal masts, putting things in buildings. Lots of things that are out there, and I'll show you some of my favorites. A good crimper is worth its weight in gold. This particular one is made by a company called IWIS, I guess is how you pronounce it. It's a whopping 23 bucks from Amazon. I sometimes wish I had 2 of them, maybe 3 scattered around here and there. They're great. They crimp those pins on the end of those tiny little wires. I've found that it works great. They're very reliable. It's a ratchet device. You put the blank pin into the jaws on the left. You slide the wire in the other side very carefully, and you squeeze. And when you're done, if you haven't destroyed the pin in the process, which again, it takes a little practice, you'll have something that can plug into those headers and make your own plugs. Soldering stations. I'm not a big fan of the 25 watt or 45 watt soldering irons. I like the soldering station. I like to set the temperature that I need and let it stay there. Generally, they're better quality than your typical 45 watt soldering iron. It's easier to get burned with the soldering iron that you plug in. It just heats like crazy. I found this does not burn me as much. It gives you better static protection when you're dealing with devices like this. And you can get them with all kinds of prices. You can find a lot of these on Amazon. Some will have digital readouts, which are really nice. The one I have 2 of them. I use one around the layout. The dial on it just indicates the temperature you're using. And the one on my workbench has a really nice digital readout that I just had to have. So it's really nice too. But I'm able to set that temperature because I know the melting point of the solder that I use and not make it too hot or too cold. Now, again, with soldering, you want to make sure you set the temperature higher than the soldering melting point, because it'll take forever for the device, for whatever you're soldering together, to get hot. Wire strippers. These are a bone of contention for me, as many people like to use cheap wire strippers. These aren't expensive. They're like 10 bucks on Amazon. They'll go down to number 30 wire. You can strip the conductors within a Cat5 cable and you're in good shape. You can strip most anything with this. They're high quality. They're very sharp. Even if you just try to nick a wire, it'll cut a pretty good hole in it. So don't use the free ones or the 98-cent ones you can get somewhere. Splurge 10 bucks and get a good one. Yeah, these are nice wire strippers. Category 5 wire can supply a lot of good hookup wire for any of these devices. But the problem is when you try to strip off the outer layer, you can often strip the cable within. They make Category 5 wire strippers. Amazon sells those. Tell I'm a fan of Amazon and some of their supplies, but you can put the wire up here at the top underneath that, in that lip. You can see the blade underneath it. You slip the wire in, you spin it around, that's where the finger hole is, and you pull it off. Don't put that wire too far in that stripper, just put it enough to where it kind of rests. You spin it, then you can pull the jacket off the wire and get to the cable underneath it, those 8 conductors that live underneath it, and not have them with nicks in them. Voltmeters, have several. They're useful. The one on the left I like because I can carry it around to different places. I use the one on the right for just mainly testing resistance and to make sure that I haven't messed something up. I have another one that I use that I'd much rather use for voltage, and it's just personal preference. It's good to have several of these guys around, and especially when you start dealing with microelectronics, you need to test your voltages and make sure that things are working correctly. Sometimes it's very difficult to know if you got things wired right without doing a quick test. And of course, the ubiquitous OptiVisor. These connections are little. My eyes aren't getting any younger, and reading glasses are fine and good, but something that really lets you see way down into whatever you're looking at really does help. Adjustable power supplies. Again, found this one on Amazon. This one was a whopping 30 bucks. It has a little voltmeter on it. The 40-buck version has a digital readout, which is kind of cool, but this one works great. I use it for powering test circuits associated with Arduinos and Raspberry Pis. When it's not working, I use it on my Sprague to program engines. The Sprague is tied into a Raspberry Pi, which then runs the decoder programmer that's supplied within JMRI. So these things are really handy to have. They're cheap. They give you a nice clean power. They give you a specific voltage. The voltage doesn't go down, which is very important when you're dealing with these things. And so you can do your tests and know that things work right. So enough of the tools. Let's talk about some more technology crap. Raspberry Pis. Capable, inexpensive, single board computers. As I showed earlier, size of the deck of cards. Has the interfaces that you need to run most anything. You can run disk drives off it, all kinds of stuff, but it doesn't have a storage device. You need to connect a keyboard, a mouse, and a monitor. You need to also have a micro SD card for storage. Yeah, it's got to have its operating system somewhere. If you want to have a fully capable computer somewhere and you really don't want to go out and drop $1,500 for a new laptop, this guy is your friend. I have 2 of them also running as media players at home, playing music. These things work great. So I haven't got one playing video, but I do use it for audio. Now, the one thing you want to be careful of with the Raspberry Pi is they do need heat sinks. And when you buy them, especially if you buy it from a vendor like Amazon or SparkFun or other ones, often they'll sell you kits with it that has a case, which is really nice to have, and some heat sinks and a power supply. So other stuff. Not much to it. It's it's about the size of a cell phone, and it does have an audio jack, which is very, very nice if you're doing something with audio. This is a genuine Pi. This is a real one. I haven't dealt with the counterfeit Pis. I haven't found any of them, thank God. Most vendors won't sell them because they don't work well. Try to make sure that you find a source that does have real ones. They're all about the same price. On the raspberrypi.org webpage, there's information telling you exactly how to tell the difference between a real one and a fake one. If you get a fake one, send it back. There's the underside of a Pi. Again, having a case is nice. See all those nice little pins in there that can short out? Well, don't do that. And they have nice interfaces. 4 USB connectors. This one has 40 output pins that you can control. It has an Ethernet connector. Really nice. They're nice little gadgets. This Raspberry Pi 3 has a gig of RAM on board. Has a 1.2 gigahertz processor, 40 pins, camera port, an HDMI connector for your monitor, and make sure your power supply is good enough to handle what the Raspberry Pi eats. Some of the older power supplies won't work with the newer Raspberries. So just be careful when you get one. You may want to get a power supply with it to make sure it works. And of course, the new Raspberry Pi 4, you can see at the bottom, we have a couple of HDMI ports. I'm wanting to use one of these for my dispatch panel because I'll be able to hook 2 monitors up to it and make life a little bit easier for the dispatcher. And considering the price point, anywhere last check, mid 40s to 60 bucks, that's really not bad. Yeah, the monitors are going to cost me a lot more. I run JMRI on one of my Pis, and it interfaces the CMRI system. Use it for programming engines. I use a Sprague, or Sprague 2, I think is what you probably get now. Runs JMRI's Decoder Pro software. You can run, you can have one Pi running JMRI and another one accessing it remotely and showing the screens from it. There's a lot of things that you can do with the Raspberry Pis, but basically anything that you could do with a PC, you can do with a Raspberry Pi for much less, and a lot smaller form factor. As an example of a Raspberry Pi being used on my previous layout, I have my Raspberry Pi on the lower right-hand side. It interfaces, it's had a little serial controller program that I used, that I found on the internet, and it connects to a connector at the top that takes it out RS-45 output through a serial port. It worked great. It worked as well as the laptop. I could turn it on, start JMRI, the layout ran, and I wouldn't have to worry about, gee, is the laptop going to crash or anything? Or for that matter, I could have a spare Raspberry Pi sitting waiting in case the first one died during an operating session or an open house. Not that kind of stuff ever happens. But this has been really great because I don't have to deal with an extra computer. Now, again, why using these things? They're cheap, they're plentiful. The programmer for Arduinos is free. For that matter, the operating system for a Raspberry Pi is free. They're flexible and expandable. The resources to make them do other things are readily available. I have an Arduino that has a soundboard connected to it that makes the grade crossing ring the bell. You can use them for animation, lighting, signaling, controlling relays, RFID, model rail control systems. Folks have an RFID system that runs using Arduinos and other small computers. You can control servos. You can access LocalNet. There's a set of software called DCC++ that allows you to talk to DCC and actually create a DCC controller for your layout and not having to use any commercial systems. These things are amazing. Give you an example of an apartment building that I have on the layout that looks like the TV antenna broke off on it. But anyway, this is the one I built and unfortunately never installed because I finished it right before we decided we would move. But it's going to be on my new layout. And this is the outside of it, which is, standard building, no big deal. It needs weathering, but it's there. But underneath it is a little Arduino, and there are 8 pins of this guy. Here, I'm hoping you can see my mouse. I'm looking at the lower right-hand side, and you can see the resistors plugged into that DuPont plug, and those go to the lights in there. I feed the building with 9 volts when I want everything to turn on, and the Raspberry Pi, the Arduino underneath it, then takes the 9 volts. It actually will reduce it down to 5 volts and runs the LEDs. and it runs them randomly as an apartment would do, has the bathroom light coming on and has a bedroom light coming on, other things like that. So in 8 was enough on this because this is kind of a background building. I'm building currently an interlocking that uses 2 single crossovers, and I'm in the process of developing the interlocking code. It uses an Arduino Mega. It'll control the signals. It'll control the yard master panel because this is the entrance or the yard throat of a yard. It'll control the signal bridge going into it and leaving it and all the other things. Plus, as you can see below the Arduino Mega, there are 2 relays, or actually there are 4 relays. They're set up as 2 double pole, double throw relays to control the actual turnouts on the, or control the polarity of the turnouts on the crossing. Also, there's a wire that goes to what's further down the line that controls the layout, the polarity of the island that this feeds. But you can do these kind of things, saves a lot of work, a lot of toggle switches, a lot of relays, makes life a whole lot easier. The development environment that you can get for Arduinos is available at www.arduino.cc. It's in the download section. It is in reality a C compiler or a C++ compiler. Don't be afraid of that. There's a lot of free software out there. There's a lot of information on how to program in C that's available for free. The Arduino crowd doesn't make any big deal about folks running counterfeits. They're happy with that. They have no, they just say, you know, just please donate to our compiler and life is good. So they also will deal with any Arduino board you have. If you have a USB port, it will download the code that you've written to the Arduino. You can test it. It's really a nice system they have. Plus, it has sample code built into it. For deal with powering these things, I've used batteries, 6 volts. I've used voltage bucks and wall boards. You can get a little battery power for an Arduino. That's nice. Or you can use this on a Raspberry Pi. Wall warts. Make sure your wall warts are regulated. You can find a lot of them that are not regulated. A regulated power supply, if it's spitting out 6 volts, what ends up happening is if you add load to that, if it's unregulated, the 6 volts will drop. If it's regulated, it adds more juice to it and makes it and keeps it at 6 volts. So you want to make certain that you use a regulated power supply for your Pi or your Arduino. This is where I use voltage bucks. I often will run a 12-volt bus around the layout and use a voltage buck to drop things down to 6 volts or 9 volts for buildings. It's good not to make the difference between what the output is and the input too large because you don't want your voltage buck to get hot, but it ends up creating regulated voltage for your for whatever the application is you're using. Be careful though in purchasing the voltage bucks. There are some that get some crappy reviews for reasons, and some of the reasons, the good reasons are, as it's been known to have voltage bucks will spit out the source voltage before it lowers it. That can be very bad for whatever you're connecting to. So make sure that the bucks you use have good reviews or come from a quality source. But generally, the Unos have metal USB connectors. If you're stacking boards on top of it, make sure you don't short those out. Enough said on that one. That's from personal experience. When you're compiling Arduino code, make sure you read the error messages and start at the top. Don't start at the bottom and work your way back. When you make sure that you test things on the workbench, check your solder joints, make sure that they're good, and have a spare for these things. Now, a lot of things done with Arduinos. I'll talk about some books in just a second. A lot of code is available on the internet, and that's one of the best sources I find for code. I used to write code for a living, but I'll be damned, I just soon use somebody else's if I can. One thing you may have to get used to is the best way to connect to an Arduino or any digital device is what they call current sinking, or common anode. You don't supply the voltage through the device that you're using, the Arduino just grounds it. When you use that, it reduces the amount of interference that you can receive. So all your lights or signals are connected to a common positive power supply out on the layout, and the Arduino then just grounds it. You might, a lot of the signal companies all have the post, I think the Tomar signals, the post is positive, and you just ground the wire and the light comes on. Keep spare devices. Static electricity can be an issue. I've been lucky so far. I've had humidifiers installed for the winter, at least in our previous house. Haven't done it yet here. I'm keeping my fingers crossed. During the summer, make sure you have air conditioning to keep the humidity stable. Surge protection on your power supplies is really good to have. And don't overload your Arduino. Arduinos handle enough for an LED for each pin output. And I'm talking about low brightness LEDs. Some of the newer LEDs work great on that. Look at the specs on them, look at the maximum current drain on each one to make sure you don't overload your Arduino and make the magic smoke come out. With Raspberry Pis, make sure you get a good case, get a good power supply. Don't lose the micro SD card, or mix it up with some other ones, because things will work in a different manner. So I try to label the little micro SD cards so I'll know exactly what Pi it came from. So Arduinos are in a lot of flavors. Pis can replace the use of laptops and desktops. Use good tools. Amazon has what you want. A lot of codes available online for the right price. Arduino.cc has a lot of good sample code. Simon Monk's written a couple of books that I kind of like about Arduinos. This is the book Arduino for Dummies also. But really, you don't totally need those. You can get most of the information you need online. For hardware, SparkFun.com is a really good supplier. Pololu does a lot of robotic stuff. They have a lot of those pins and plugs. ModernDevice.com, again, really good high quality supplier of the parts. Amazon has a lot of stuff, and in reality, I order a lot from them. A lot of their boards are knockoffs. eBay is almost guaranteed to be a knockoff, but for that matter, I've known some people that buy some stuff from eBay, and they'll buy like 20 boards at a time for $1 each, and if 2 or 3 don't work, who cares? So, something to be aware of. You can use DigiKey and Mouser. They're good for unique items. They're more industrial, more dealing with more the industrial community. A lot of their gear is very high quality, and unfortunately, the price follows it. Sample code, again, I mentioned Arduino.cc. Dr. Jeff Bunza has some great articles in the December 2016 and March 2017 issues. And he also has sample code associated with it. Shows you how to build some boards. It's really very nice. The Arduino discussion groups and groups.io are really handy also. So that's it. I want you to do some of these things. I would, wow me with what you can do with Arduinos. I've seen some amazing stuff with it. This is an accessory board that I have. As an Arduino Leo, it's a CMRI node. It has relays to run some things. There's a signal crossing device over here on the right. If you can see my mouse, it has a soundboard attached to it. A couple of bucks on the bottom. This runs buildings, and The relays control 9 volts feeding different buildings. So very, very handy. So with that, I'll stop the sharing and go ahead and return and do a Q&A. Let's hope that works.
Yes, so far.
Yay!
Yes, sir. First question that popped up was, is the code you use or strip out, is the code for an Arduino the same that you would use on a Raspberry Pi?
Not really, because in Arduino, you're writing code for things to work. A Raspberry Pi, granted, you probably could use similar code, but a Raspberry Pi is more of a personal computer. So
different functions then.
Different functions. I know some people that have written code for a Raspberry Pi, and you can write it in C just like you could for an Arduino, but it's easier to write for an Arduino to write the C code for an Arduino and just turn it on and off with a Pi.
Now, the Arduino that you had mounted in your apartment building to randomly turn lights on and off, did that Arduino come configured to randomly turn lights on and off?
No, it didn't. I had to write the code to do that. I
Okay.
found code online that would make a clock tick every second, and I would count those ticks. And after like 30 seconds, I would turn on the light, and it would keep counting ticks and counting ticks. And every time the Arduino just loops through the code, it would look at that tick count and say, "Oh, it's gone to 45 seconds. I need to turn that light off." So it would turn the light off. So it was just more going through. Oh, we got a thunderstorm nearby, by the way. So got a flicker in the lights.
Oh, it's
Yeah.
calm here. So it wasn't truly random, but it gave the impression of random turning lights on and off because it was counting ticks, and as long as you didn't stand there long enough, you would get the feeling that someone ran into the bathroom, turned the lights on, stayed there for a little bit, turned the lights off, and you might not see it again. Okay.
Exactly. You could do it randomly if you wanted, but I wanted there to be some reasonable thing. Somebody turns on the light in the room and then turns on the bathroom light, goes for 30 seconds, a minute, and then turns off the bathroom light. And for that matter, I'm thinking about putting the flicker for a TV in there. So Jeff Bunza.
Now that would work. Now that would be kind of cool.
Yeah, Jeff Bunza's code has how to make an LED flicker like old black and white TV. So I'm looking forward to doing that one.
Interesting. The next question was, what software tools do you need to control a 40 pin? Because I'm not sure what a 40 pin is, but you were mentioning a 40 pin connector on, I guess, the Arduino. I mean, excuse me, on the Raspberry Pi.
Probably the Pi. I use programs on the built-in programs. The Pi that I have as an example actually uses a small program that I configured it to have the serial output go out those particular pins. I didn't write any code for the Raspberry Pi at all. And for that matter, if you're using a Pi with a Sprog, you plug the Sprog in, you load JMRI, it's happy. So I don't use the 40 pins for the Pi except for any kind of outside accessories. And I use other people's software because I'm too lazy to write my own.
I understand that. I don't like authoring software. I've done it. And, one of the questions was, could you use an Arduino to make your own DCC decoder?
Yes, there's some people that are doing that.
Well, that would be interesting.
It wouldn't be, it's not small, but a number of people are doing it for accessory decoders. Those are out there. And if you look on the boards, the Arduino for model railroading board on groups.io, there are people that have done that. There have been discussions about them. So yes.
Interesting. Okay. And You use the term a buck, a voltage buck. I've never heard the term buck before for a device.
Okay, it's a device used to lower voltage. It's kind of like a transformer, where
Okay.
you have a step down transformer. The buck lowers the voltage, say from 12 volts down to 9 volts or 6 volts or whatever. And it gives it without having to have this big heavy transformer there. The buck does it with effectively solid state and does a lot better job of controlling the voltage on the output.
Okay, cool. I haven't seen any more questions pop in here or here. So I think we've got questions. We got the questions asked. Brad, anything else you want to
I've
ask
got
about?
2 questions that I'll throw at you. The first one is, what's the limitation of an Arduino in relation to how many LEDs can I hook up to one pin?
I wouldn't really start hooking more than one LED per pin.
Okay, so is that based on that each pin has a maximum amp draw?
Yes. Each pin has a maximum amp draw, and in the specs of the Arduino, you'll find that. And there's a total amp draw that the MTEL processor can handle. So you not only have to look at the individual pins draw, you have to look at the sum total of those pins. Generally, I haven't run into a problem with them. You can hook 16 up. I've had all 16 come on before, and it hasn't let out magic smoke. So you should be generally okay. If you get beyond that, you may want to be a little careful, or for that matter, use more up-to-date or modern LEDs that don't draw as much current. A lot of the LEDs draw 8 or 9 milliamps, and that's perfectly fine for an Arduino. They're happy with that.
Okay, is there any online tools or software that you can run a simulation of an Arduino sketch that you know of? So you don't have to buy
No,
any of the components or anything and you can test it.
the components are so cheap. Just buy a kit from Amazon and go with it. I don't know of anything that you can get online that will simulate one. There may be something out there, but I've never seen it.
Okay. Oh, I think that's about all that I can see. How about you, Perry? Got anything
That's
else to
that.
add?
It more knowledge than I have already. I appreciate it.
Oh, sure. I enjoy doing that.
Okay,
Never
Tom.
done one on I've done presentations sitting down before, but that was a long time ago. Brad, are you in Australia?
I am.
It was in Sydney about 20 years ago when I worked for Microsoft. And I had jet lag like you wouldn't believe. And I was standing up behind the podium giving a presentation, and it hit me. So I sat down on the edge of the stage and finished the presentation.
Oh, that sounds exactly like me and Martin. We've been jetting around the countryside for the last, or the world for the last 3 or 4 months, and yeah, we're always jet lagged here. So
Yeah.
I'd like to just thank you, Tom, for a great presentation, and it's always good to get this sort of technology out there and show people what's around.
Okay. Well, thank you very much.